Hi, I'm Raina Fitzgerald, and in this lesson we're going to be looking at solving systems of linear equations graphically. When we're talking about linear equations, we're talking about lines, because a linear equation graphs as a line. And here I have a line 1. Now let's draw another line. This line, which is now red, is our line 2. Okay, let me move line 1 down and line 2 up. And imagine that we graph these two lines one on top of the other. They're superimposed. What we can see is that these lines intersect at a point. This is the point of intersection. So this point of intersection is x1, y1. It's a valid point that can be represented as an ordered pair. When two lines intersect such that they touch, we say that the lines are consistent. When these same two lines are not the same line but separate lines, we say they're independent. So line 1 and line 2 are consistent because they do touch, but independent because they're two distinct lines. Here I've drawn another line. This is line 3. And here is line 4. Line 3 and line 4 are parallel. And the mathematical symbol for parallel is to put an arrow on both lines. And let's write line 3 is parallel to line 4. If two lines are parallel, and I want to say on a flat surface, because the universe is curved, and I won't get into that, but on a flat surface, if two lines are parallel, then they never intersect. So when two lines never intersect, we say they're inconsistent. And they are also independent lines. So these are independent lines that are inconsistent. Over to the left, we have line 1 and line 2 are consistent because they do touch, and line 3 and line 4 are inconsistent because they never touch because they're parallel. Below, I have a line 5 in black. Imagine I have another line, line 6, and that when I graph line 6, I find that line 6 lands right on top of line 5 because in fact line 6 and line 5 are the same line. Well, this means that line 6 and line 5 touch at every single point on their lines because in fact they're the same line. Here, line 5 and line 6, being the same line, are considered dependent. They are dependent upon each other because in fact they're the same line. They are not independent. They're also consistent because they always touch. Let's go back over these again. In our first situation, where our lines touch at one point, we say that they are consistent and independent. In some cases, it's sufficient to say that the two lines are consistent. Independence is implied. In the second situation, where the lines are parallel, we could simply say that they are inconsistent, because if two lines are inconsistent, then they are parallel, which means they are clearly independent. In the third case, where the lines are the same line, we could merely say that they are dependent, They're dependent because they're actually the same line, because dependent lines are always consistent. In the first case, the solution to lines 1 and 2 are the xy point. That is x1, y1. So the solution is the ordered pair where the lines intersect. A solution represents where lines touch. Let's look at the second situation. In the second situation, these lines never touch. So in this case, we say that there's no solution. Line 3 and 4 as a system have no solution. In this last case, for line 6 and 5, we say that the solution is actually the line itself. So let's imagine that line 6 and 5 are equal to the line y equals mx plus b, where m is the slope and b is the y-intercept. In this particular case, the solution is the line itself. So the solution to this, in fact, is the line y equals mx plus b. These three diagrams, with line 1 and 2, line 3 and 4, line 5 and 6, represent three systems of two linear equations. So when we're talking about a system of two linear equations, we're talking about two lines and how they meet. And there are three possibilities. The lines will intersect at one point, the lines will never intersect because they're parallel, or the lines will intersect at all points because the two lines are the same. When we're looking for the solution of systems of two linear equations, the solution are where they intersect. So the solution for our first system of equations, line 1 and 2, are the ordered pair x1, y1. The solution to our second set of equations, line 3 and 4, and this is the second system of linear equations, is that there is no solution because they never touch. And the solution to our third system of linear equations, line 5 and line 6, in fact is the line itself because they touch at all points on the line. Here we're going to solve a system of equations by graphing. Here's our system of equations. We have two linear equations, and each equation represents a line. The brace that we see here to the left represents that we're grouping these two lines together into a system. Let's call our first line line 1. Line 1 has a slope of 2 and a y-intercept of 1. So let's graph that in red. Here's the y-intercept in red at y equals 1. Now our slope is 2, which means from this point we're going to go up 1, 2, over 1, and that puts us at our second point. 2 points determine a unique line, so let's go ahead and connect those points, and this is freehand, so I'm making this as straight as I can. And here we have our line. So this is line 1. Now we're going to graph line 2 in blue. So here is line 2. Line 2 has a slope of negative 1/3 and a y-intercept of 9. Let's go find the y-intercept. Right here, where y is equal to 9. Our slope is negative 1/3. So we're going to go down 1 for the negative 1, to the right 3. 1, 2, 3. So this gives us our second point. Now we want to draw a line through those 2 points like this. The solution to these 2 lines, this system of equations of line 1 and line 2, is where they intersect. And their point of intersection is approximately right here. To solve this equation, well, we're solving by graphing. So when we solve by graphing, we sort of ballpark it. Try to find our x value, try to find our y value. The x value looks like 1, 2, 3. If this is 4, our x value looks about 4.5. And if this is 9 and this is 8, then our y value looks to be just a little bit under 8, 7.8. So we're going to sort of guess that the ordered pair here, the point of intersection, is about 3.5 is our x-coordinate, and our y-coordinate, let's say it's 7 3/4. Now, this is not very accurate. This is sort of a ballpark answer for our solution. We'll put a box around our solution because solving by graphing is not that accurate. It's just what your eye can see. But this is one way to solve a system of linear equations. Here, we're going to look at solving a system of linear equations by graphing again, and this time, here's our system of 2 linear equations. Our first line, we'll call this line 1, has a slope of 1/2 and a y-intercept of 1. So let's graph it. Here's the y-intercept at y equals 1, and it has a slope of 1/2, which is up 1 over 1, 2, positioning our second point at about here. Let's connect these 2 points into a continuous line. And here we have line 1. Now let's graph line 2 in red. Line 2 has a slope of 2 over 4 and a y-intercept. Well, let's change this to add the opposite. So a y-intercept of -4. Let's also notice that our slope, which is 2 over 4, can be reduced to 1/2. So the slope for line 2 is 1/2, which in fact is the same slope for line 1. So these 2 lines have the same slope. The difference is that our red line, line 2, goes through the point -4. And let's go ahead and put the slope in. So starting at the point, the y-intercept of -4, we're going to go with a slope of 1/2 up 1 over 1, 2. And this gives us our second point. Now the slope of these 2 lines are the same. Let's go ahead and draw line 2. Line 2 has the same slope as line 1, but a different y-intercept. The y-intercept for line 2 is 0, -4, and the y-intercept for line 1 is 0, 1. So these 2 lines are, in fact, parallel. Let's put the symbol for parallel, and we can say that line 1 is parallel to line 2, and the reason we know this for certain is because the slope for line 1 is equal to the slope for line 2, and when the slopes are equal, then the lines are parallel. So in this case, when we're asked to find the solution, these 2 lines never intersect. So we would write that there's no solution to this system of linear equations. And let's put a box around this because this is our final answer. This is our last example of solving a system of linear equations by graphing. Here's our system of linear equations. So we have two equations, and our first equation, we'll call it line 1. We're going to graph it. And this line has a slope of negative 1/3, and the y-intercept, well, if we change this to add the opposite, we can see that the y-intercept is negative 1. So I'm going to position myself at approximately where negative 1 would be. That's my y-intercept at negative 1. And my slope is a negative 1/3. So I'm going to say a negative 1/3. So I'm going to go down 1, and then I'm going to go to the right 1, 2, 3. And so my second point that I've established is right here. And I'm going to freehand here connect these points as best I can in a straight line. So here we have, this is our line 1. Imagine that I have this right. Okay, here is line 2, and I hope that you're noticing something. Line 2 has the same y-intercept. The slope is negative 2/3. Well, let's reduce that slope. This slope, m, for line 2 is negative 2, I think I said over 3, negative 2/6, which reduces to negative 1/3. Notice that the slope for line 2 is now actually equal to the slope to line 1, which means they have the same slope. They have the same y-intercept and the same slope. So if we go ahead and put a point at the y-intercept and put another point after going through the slope of down 1/3, we're going to go ahead and graph this line and find out that the red line, which is our line 2, superimposed on top of line 1, demonstrates that line 1 and line 2 are actually the same line. So in this case, we want to know, how do we write the solution when it's the same line? Well, the solution is basically the equation for the line itself. You can write the equation for the line in any format. I'll use the top equation. Y is equal to a negative 1/3 x minus 1. This is actually the solution to this system of equations. And what it tells us is that for any given x value, if you plug it into this function and it outputs a y value, that x and y ordered pair based on this function relation satisfies this system of linear equations. Every point on this line is where these two lines intersect because they are the same line.